All right, welcome everybody to our presentation today. We'll just wait another moment or so for it to be 10 o'clock and then we'll get started. Thanks everyone for being here for our presentation. All right, so welcome everybody to our talk today. My name is Jase Bernhardt. I'm an assistant professor at Hofstra University and also the incoming director of sustainability studies here at Hofstra. Today we'll be speaking about the 2020 hurricane season and talking a bit about what it's like to prepare for hurricane season during a pandemic. So today we will be discussing the following topics. First, we'll go through some basics about hurricanes. How do they form and when do they form and why do they form? Then we'll focus in a bit on the upcoming 2020 hurricane season, which you may have noticed is already off to a quick start. Then we'll delve a bit into the history of Long Island hurricanes, and then end our discussion with some talk about how we communicate hurricane warnings and the particular challenges we'll face this year, given the overall public health circumstances that have been occurring. If you have any questions throughout the presentation, feel free to type them into the YouTube chat box. I'll take some of them during the talk, and any that I don't get to during the talk, I will answer after the talk. So feel free to also ask questions as we wrap up. So we'll start today by discussing what exactly is a hurricane. A hurricane is a type of tropical cyclone. As meteorologists, we prefer the term tropical cyclone because it's a broader term that refers to storms that occur anywhere across the world in tropical ocean waters. We call them hurricanes specifically in parts of the Atlantic Ocean and Eastern Pacific Ocean. Other parts of the world have different names for these storms. They're the same type of storm, but they're called something different in other places. So we use the broad term tropical cyclone in meteorology and climate communication. A hurricane or tropical cyclone is a large rotating storm that forms over these warm tropical ocean waters. Essentially, it's a bunch of scattered thunderstorms that begin to organize and rotate around. And once that rotation begins, the storms can really start to strengthen and form a coherent low pressure system or cyclone. And that's when you can start to get a strong hurricane forming. As we see in the image on the right here, the satellite imagery of Hurricane Michael, which actually struck the panhandle of Florida as a Category 5 storm, the strongest type of storm, back in October of 2018. Important to note that these low pressure systems, which are tropical cyclones, are a bit different than some of the low pressure systems we see here more frequently in the Northeast US. For example, coastal winter storms or the low pressure storms during the summer that bring rain and clouds and storms are often composed of clashing air masses, as we like to say in meteorology, where you have warmer, moister air mixing with colder, drier air, and that can often spin up a nice storm. A hurricane, however, is a bit different. Since it's a so-called tropical cyclone, it's only forming with one type of air mass, very, very warm, moist, tropical type of air. And essentially, the extreme nature of that air, it's very hot and very moist, allows it to form this powerful rotating circular storm known as a hurricane or tropical cyclone. What are the exact ingredients we need for these hurricanes to form? So as mentioned, the number one ingredient for hurricanes, really the food that they need to form and then strengthen and last, is very warm ocean temperatures, preferably at least about 80 degrees Fahrenheit. So that's a bit warmer than the ocean temperature we typically see off Long Island, for example. So really only the warmest ocean region of the world, the tropics and the area just above the tropics, the subtropics, are the places where we see ocean waters this warm. And even then, it's only during certain times of year, during the warm season, when the ocean waters are warm enough to consistently support these types of storms. In addition to having that warm ocean water at the surface, you also want it to extend down a bit through the ocean. What happens is hurricanes are so strong, they churn up lots of waves and can even draw up water from well below the surface of the ocean. So as the hurricanes bring up that cooler water from below the surface of the ocean where sun doesn't get to as readily, the water is often cooler. So if hurricanes can easily churn up cool water, then that will sort of weaken them, will sort of force themselves to weaken, because then the cooler ocean water will be below 80 degrees Fahrenheit and there won't be enough energy for the hurricane to last. So hurricanes really form the best when that warm ocean water extends at least a few hundred feet down to the ocean. That way, even when the hurricane starts churning up that ocean water, we still see warm enough ocean water at the surface for the hurricane to feed on. Hurricanes also can't form right near the equator. They need a spin due to the rotation of the Earth, and right near the equator, because the Earth's radius stays the same, you don't get that special spin. It's called the Coriolis force. It's a bit more of an advanced concept, but just the basic takeaway is for hurricanes to form, they're typically at least 5 degrees latitude north or south of the equator. So this really gives us a zone, a sweet spot of about 5 degrees north or south of the equator to about 20 degrees north or south of the equator, where you have that spin being imparted onto a storm. You have the warm enough ocean waters that also extend deep enough below the surface. And also you have this last factor, which is a low amount of so-called wind shear in the atmosphere. And wind shear is just the change in speed and direction of wind with height. So as you go up in the air, up in the atmosphere, the speed and direction of wind often changes. Violent wind shear is actually good for one type of severe weather, tornadoes. To get tornadoes, you of course need lots of spin. So the wind shear is good for tornadoes, but wind shear is actually bad for hurricanes. They sort of are big and strong enough to create their own circulation, their own spin. So if the atmosphere also has a spin in it, that's actually going to act to weaken the hurricane. So you want light winds higher up in the air, higher up in the atmosphere, and little change of speed and direction of wind with height, so low amounts of wind shear. So all these factors coming together provide a favorable environment for a hurricane to form. Doesn't necessarily mean a hurricane is going to form, but it means there's a better possibility of something brewing when you have these conditions being met. So again, as you can see, hurricanes form a little bit away from the equator and then up to about 20 to 25 degrees away from the equator. And we call these tropical systems different things depending on which parts of the world they're in. So most familiar to us, of course, is the term hurricanes. And these tropical cyclones, these storms, are called hurricanes if they're in the North Atlantic Ocean or the Eastern Pacific Ocean. But they're called typhoons in the Western Pacific and then cyclones in the Indian Ocean. It's the same type of storm. A typhoon is the same thing as a hurricane, and a cyclone is the same thing as well, but each region has its own preferred name. But we'll, of course, be focusing on hurricanes in the Atlantic Ocean for this talk because those are the ones that have the impact on Long Island. And notice here in the Atlantic Ocean, we are able to have hurricanes sometimes lasting a bit further away from the equator. And that's due to a warm current of ocean water you might have heard of called the Gulf Stream. The Gulf Stream transports very warm ocean water in the North Atlantic from near the equator up along the East Coast and even up towards Southeast Canada and up towards Greenland and Iceland. And that Gulf Stream brings in much warmer water than you should see for that latitude, which occasionally allows hurricanes to come up the East Coast and sometimes even impact Long Island directly or indirectly. So it's our unique physical geography around here, that warm ocean current, the Gulf Stream, which helps to foster the occasional hurricane that can impact the eastern United States coast and places like Long Island. When do Atlantic hurricanes form? Well, as we mentioned, they form during the warm season, but there's a bit of a lag from when you might most expect them. If you think about when is it warmest on land in the eastern US, generally the warmest week of the year is late July, and it can vary a little bit, but we're thinking July into August is the warmest time of the year on land. But it takes a lot of energy to warm up ocean water. Water takes more energy to heat up than dry land. So it turns out the oceans take even longer to warm up during the summer. Therefore, oceans actually peak in their temperature in the Atlantic Ocean late in August and into early September. And since warm ocean waters is the top factor for getting hurricanes to form, hurricane formation frequency will actually generally follow the pattern of warmest ocean waters. So the average peak of hurricane season in the Atlantic Ocean is actually September 10th, because on average, that's around the time when the oceans are warmest. So the average hurricane season, of course, each season is going to be a little bit different. sees usually a pretty slow start. There can be some hurricanes forming in May and June, and then June 1 is the official start of the hurricane season. Though sometimes storms can form before then, as we've seen this year. And generally, things are pretty quiet June into the first part of July, and really often into August. Come August, now the oceans have really started to warm up. So we see a big peak rise in hurricane activity through August, that peak into early September. And still, we often see a lot of hurricanes through September into October because the ocean waters are still pretty warm. Then finally, by November, it starts to drop off, but still November can often see hurricanes. And then finally, by late November, it usually drops off. And the season officially ends at the end of November, though we can see hurricanes form during any month of the year, though they're quite rare outside of the official hurricane season. So a few storms can form in June and many more form in September. So as you might expect, geographically, the range of where hurricanes, tropical storms and hurricanes can form expands as the season peaks. So in June, when we do see tropical cyclones forming, they're generally going to be where the warmest ocean waters are. And the ocean waters warm up the quickest where you have sort of more shallow and smaller bodies of water in the Atlantic Ocean. Specifically, that's the Gulf of Mexico and the Caribbean Sea. So generally, if hurricanes are going to form early in the season, we're going to see them in those locations. So we see the blue and green highlighting in this map on the left here. That's the most likely place for hurricanes to form, and the white arrows show the prevailing tracks. So we'll notice that hurricanes sometimes move in the Gulf of Mexico and occasionally even brush by the southeast US, maybe off the coast of North Carolina. As we go through the hurricane season, there's both more storms, and the storms can cover a larger geographic area. So by September, which is the average peak each year of hurricane season, we often see lots of storms forming in those places mentioned, the Gulf of Mexico and Caribbean Sea and Southwest Atlantic Ocean, because that's where the warmest ocean water is. But hurricanes can form all the way across the Atlantic Ocean. And many strong, long-lived hurricanes actually form off the coast of Africa and off a small chain of islands here called the Cape Verde or Cabo Verde Islands. So these hurricanes form just off of Africa, move across the Atlantic Ocean, this big white line here. Sometimes they're steered away from the east coast of the US and the Caribbean, which is good because then they don't impact land. Those are often called fish storms because it's really only the fish in the ocean that are going to see them, maybe an odd cruise ship that didn't get the memo. But other times the hurricanes are forced towards the Caribbean or the Gulf of Mexico or the southeast US or even sometimes the northeast or mid-Atlantic. And then those are the hurricanes that are often most memorable because they make landfall in the US and can bring lots of damage. How many hurricanes form each year? So of course, year to year, there can be a good amount of variability. Sometimes there might only be a few hurricanes that form, and some year there might be a dozen or even more hurricanes that form the Atlantic Ocean. So it can vary quite a bit. The longer term average we've seen over the past several decades is maybe 6 to 7 or 8 hurricanes per year on average. And then more in the way of so-called tropical storms. A tropical storm is just a weaker version of a hurricane. It has some of the same aspects of a hurricane, just weaker and more disorganized. And there's also a lower wind speed threshold. But once a system becomes a tropical storm, once a low pressure in the tropics becomes a tropical storm, or it reaches winds of about 40 miles per hour, it's going to get a name. So when you start hearing the name, you know it's a system of at least some significance. So on average, you go through about a dozen names per year, a dozen tropical storms, and it keeps that name no matter what. If it weakens, it'll just keep that name until it goes away. And if it strengthens, it'll keep that name as it becomes a hurricane. So on average, a dozen or so of these tropical storms that get a name, 6 to 7 or 8 of those on average become hurricanes. And then a few of them reach a stronger status in hurricane category. And we'll talk about those hurricane categories in just a little bit. But of course, this can vary. Some seasons will have less than this, and some seasons will have more than this. So how do we classify hurricanes? So that's where this Saffir-Simpson hurricane wind scale comes in. And these are the categories you've probably heard about before that relate to hurricanes. Really important to note that this scale only takes into account wind speed. There are many different factors and aspects of hurricanes. It's not just the winds. They can bring rains and flooding from storm surge. They can be really big or they can be smaller. They can move fast or slow. And all those characteristics of a hurricane can influence how much damage they can bring. However, the Saffir-Simpson hurricane wind scale, given its name, just looks at the wind speed of hurricanes, which is a very important factor, but not the only thing. But it's sort of the easiest, quickest way to sort of give a category of increasing severity, classify hurricanes. It was developed by two individuals, Saffir and Simpson. One was a hurricane scientist, the other was an engineer. So they're mainly looking at what different types of wind speeds can bring damage to different sorts of buildings. So it can be classified a tropical storm, a tropical system, once it reaches winds about 40 miles per hour, but wind damage from a tropical storm is pretty minimal. So 74 miles per hour is a cutoff to be a hurricane. Once you reach winds of 74 miles per hour, this is so-called sustained winds. We have to have that wind averaging for a whole minute, not just the instantaneous gust. So once you have 1 minute average wind of at least 74 miles per hour, that can bring some damage even to homes. So blowing roof shingles off, bringing down fairly large tree branches, which can get on homes and things of that nature. Mobile homes, fully constructed homes, can take on some significant damage. So 74 miles per hour is a cutoff for a hurricane because that's when you really start seeing notable damage to structures. Then you have category 2. Once the winds reach 96 miles per hour, that's even more extensive damage to homes. Then once you reach category 3, that's the cutoff for so-called major hurricane. So major hurricane categories 3, 4, and 5, that's when you start getting devastating damage to homes. Even well-constructed homes can take on significant damage. Windows being blown out, roof shingles being blown away, and maybe even more significant damage to less well-constructed homes, like roof failure. So category 3 is when you really start getting concerned. Winds over 110 miles per hour and really can be a problem. Anyone in the path needs to evacuate. And then category 4, 130 mile per hour winds. Category 5, winds of over 156 miles per hour. Once you get to these categories here, 4 and 5, you're talking catastrophic damage. Even well-constructed homes are going to suffer significant damage, if not total failure, unless they are made with really strict construction guidelines in mind. So again, Saffir-Simpson scale just looks at the winds, but is a good, quick, and easy way to classify hurricane strength. But again, it's only one aspect of hurricane strength, not everything. So what makes a hurricane so dangerous? So we talked about the wind, and then the water is a big part of hurricanes as well. So a hurricane might not have very strong winds, but can bring a lot of flooding from storm surge and rain. So that's why you don't just want to focus on the category of a hurricane. And the case in point we'll talk about for Long Island, of course, is Sandy, which is only a category 1 storm. So the wind damage was less. But if you're around Long Island for Sandy, you know the water damage was very formidable. So that's just one important lesson in not just focusing on the wind speed and category of hurricane. And in particular for Long Island, the storm surge flooding is what we often are worried about the most. That's typically the biggest danger for Long Island during a hurricane. Freshwater flooding is often biggest in places further inland where you have freshwater lakes and rivers and streams. Those can flood pretty easily when you have several inches of rain falling from the sky in a hurricane. That sometimes happens on Long Island, but the big thing usually is the so-called storm surge flooding. So what exactly is storm surge flooding? Storm surge, the definition, is that extra water pushed onshore by the winds of a hurricane, and especially as it's getting close and then making landfall in a coastal region. So as you can imagine, the big, strong nature of hurricanes, they can be hundreds of miles across sometimes. They have very strong winds over that distance. And those strong winds and big size hurricanes allow them to whip up waves and water. Over the open ocean, hurricanes can whip up waves that could be 50, 60, 70, 80 feet. And then as you get closer to the coastline, the waves aren't quite that large, but you do see lots of extra water being whipped up by the hurricane, being formed by the winds of the hurricane. So the storm surge is any water that comes in on top of the normal tide. So as you know, the tides mean different levels of water come in and out throughout the day. So high tide, maybe a few more feet of water come in. Low tide, a few less feet of water coming in. So the storm surge from a hurricane is any water on top of that normal amount of tide. So if, say, the tide is normally going to be 2 feet, as you see in the diagram here um, at the bottom of this slide, and then there's a 17-foot tide coming in from the hurricane, the storm surge is 15 feet because there's 15 extra feet of water coming in. And then 17 feet is a total storm tide coming in. So as you can imagine, once you start getting a few or more extra feet of water, the coastline isn't used to that type of water. So unless there's a seawall or some really good protection agent, that water is going to get inland and cause flooding along the coast and in low-lying areas, even going away from the coast a little bit. And storm surge amount can get very, very complicated to model. So usually when a hurricane is approaching, you're given a range of projected storm surge, like maybe 5 to 8 feet of storm surge that can come in from a hurricane, or 7 to 11 feet, some sort of range. That's because there's many different factors which dictate the storm surge. Generally, the stronger the hurricane, the more storm surge, but it gets more complicated than that. A larger hurricane can create more storm surge. Hurricanes moving more slowly, the storm surge can be larger, or at the very least more damaging because it might extend over several tidal cycles. So each subsequent high tide where all that water comes in, there'd be more damage than the last. And also the track of a hurricane and the physical geography of the coastline it's hitting, that can all impact surge. And unfortunately, Long Island is particularly vulnerable to surge due to its physical geography. Think about the south shore of Long Island. It's very flat. It's a glacial outwash plain. It's silt and mud that melted off from the glaciers from the last ice age. It only got down to the northern part of Long Island in New York City. So the south shore, therefore, is very flat. It's this material that slowly fell away from the glacier. So the flat nature of the south shore of Long Island, and of course the flat barrier islands like Fire Island, Jones Beach, and Long Beach, those are all very vulnerable to storm surge because they're flat. So once you start putting in a few feet of water, unfortunately, it can overtop the barrier islands, and then of course come into the mainland part of Long Island as well. So the flat coastline, the fact that we have these shallow bays, storm surge is often greater in shallow bodies of water like bays, and we have bays like that in the South Shore, like the Great South Bay. So our coastal physical geography makes us especially vulnerable to storm surge. Hence why storm surge is often the biggest damage maker and deadliest part of hurricanes for Long Island. And Sandy in particular had that huge impact from the storm surge. So Sandy was a very unfortunate situation for Long Island for many reasons. And a big part of that was the storm surge. Unfortunately, Sandy was a nightmare scenario for creating a large, devastating storm surge for Long Island and New York City and coastal parts of New Jersey as well. So all the parts of our region. Even though it was only a Category 1, it had been stronger. It had been a Category 4 when it was around the Caribbean. And it was very, very large. And even though it had weakened winds, it had a very low pressure. And that just meant it was still a very powerful storm. So the size and power of Sandy allowed it to kick up a very big storm surge. The storm surge more on par with the Category 3 type of storm. And then it took, unfortunately, that nightmare track. So the image on the right there shows the track of Sandy. Notice that red line is a hurricane, then transitioned to a sort of a hybrid storm. So it almost started looking like a winter storm as it struck New Jersey. So that's why the line color changes. So hitting New Jersey is a worse track for Long Island because hurricanes in the northern hemisphere, the winds rotate counterclockwise around them. I think of the way a clock, an analog clock face, how the hands move, the winds are moving the other way. It's like a backwards clock. So counterclockwise flow, that's going to mean the east side of the storm, the right side of the storm. So think about the center line, think about the east or right-hand side of the storm. That's where the winds are going to be rotating counterclockwise or onshore. So the winds from the hurricane are going to push the water from the ocean straight into the land, into the bays, into the coast. So Sandy taking that track was the worst case scenario for Long Island. And the angle track it took, sort of picture that track and picture a line parallel to it, but close to Long Island. You can imagine that the winds from Sandy were pushing the water straight into Long Island, straight into New York Harbor, and that maximized the storm surge from Sandy. It also even hit right at high tide. So just a couple extra feet of surge came in due to the normal high tide. So that meant there were several feet of surge, again, from New Jersey all the way through Long Island. For example, the image on the left here, looking at the Bay Park power plant around East Rockaway in the South Shore of Long Island, and they got over 10 feet of flooding there from Sandy. So you can imagine that led to some significant issues for that power plant and many other adjacent parts of the South Shore. So Sandy is unfortunately a textbook example of sort of a worst case surge scenario for Long Island. All right, so that's a bit on the science of hurricanes. Let's now talk about what's going to happen, what we think might happen this year, the 2020 hurricane season. And then we'll look back at some other Long Island hurricane history. So you might have noticed the 2020 Atlantic hurricane season is off to a quick start. We had Arthur forming earlier in May, and then just yesterday we had Bertha forming. So we've already been through two of our names on the hurricane list. So you'll note this list here is the names we will use for the 2020 hurricanes that form. And again, you don't even have to be a hurricane to get a name. As soon as you get those 40-mile-per-hour winds, the tropical storm, as a somewhat organized tropical system, you get a name. So Arthur and Bertha were both fairly weak. They both just barely reached tropical storm status, about 50-mile-per-hour winds, so fairly weak. But they did acquire tropical characteristics. They were a storm, so they got the name. And this is a perfect example of the fact that we can get tropical systems forming, be it before the official start of hurricane season. The official starts June 1, but we've already seen these two tropical storms form. And it's rare, but not totally unprecedented for this to happen. It's the sixth time since we've been keeping track. So we have, going back about 1851, pretty good historical records of hurricanes, tropical storms. So it's the sixth time that's happened since 1851. So pretty uncommon, but not totally. And it last happened in 2016 and 2012. Before that, it had been a while. So we're off to a quick start, no doubt. So both those storms formed in a similar area just off the coast of the southeast US. In that area that we saw on the map is favorable for storm formation in June and even in May around the Gulf Stream, which is that warm current of ocean water off the east coast of the US. So there's sort of weak, short-lived tropical storms that took advantage of the warm ocean water there in the Gulf Stream and off the southeast to form. So we've already gone through two of our names, which means the next storm that forms, whatever that might be, is going to be Cristobal. So how does this hurricane naming convention work? So each year we have a list of hurricane names, and each ocean gets its own list. So the Atlantic Ocean has a list. The Pacific is so big it has two lists, one for the eastern part of the Pacific, near Mexico and the US, and one for the western Pacific, where they're called typhoons, out towards Japan and China and Taiwan. And then the Indian Ocean gets another list, and those are called cyclones. And then the names on those lists are meant to be named after common names in the regions, the cultural areas that are sometimes impacted by those storms. So for example, our list here in the Atlantic Ocean, the names, some of them are American in origin, because of course the US is impacted by the storms. Some of them are more Latin American origin, because of course Central America and the Caribbean can get impacted by these storms as well. So that's where our names come from. And these lists actually repeat every 6 years. So our list is similar to the list from 2014 here in 2020, and it'll repeat again in 2026. Though if a hurricane or tropical storm leads to a lot of damage and deaths, the name will be retired and then a new name will be brought about. So for example, Sandy in 2012 was of course retired because the name was, the storm was very significant, led to damage and loss of life. So in 2018, there's a new S name on the list, though they didn't actually get that far. So we see here the names also have gender parity. We alternate between male and female. So Arthur, of course, a male name, the A name. Bertha, the B name, a female name. Cristobal, C, will go back to male name. Dolly, female name, and so on and so forth. And since we started with a male name this year, next year we'll start with a female name and then go to male name. So it alternates back and forth. We also skip some letters that aren't very common. So for example, you'll see there's no Q because Q doesn't have many names associated with it, especially if you're having to retire storms. So we just skip to R. Often we don't get to the last part of the list, but some very active seasons do. We've had a few that have gone this far in the last few decades, but most of them stay in these first two columns typically. Because on average, you only have 12 or 13 storms being named. So that will get you through the L's and M's. And if a storm name isn't used in a given year, that's fine. It'll stay on the list for the next time that it comes up. So that's a bit more about those hurricane names. They're not random. There's a systematic way for naming these storms. So we'll look forward to Cristobal being named the next storm here whenever that happens. So the season's off to a quick start, and as you might have heard, we're expecting an active season. Here's the recent forecast issued by NOAA and the National Weather Service and the National Hurricane Center. Those are the government agencies in charge of tracking and forecasting hurricanes and issuing watches and warnings for them. So they're saying right now a 60% chance of an above normal hurricane season. So better odds than not of an active season. Because hurricanes are so strong and unique and take such specific conditions to form, it's impossible to say exactly how many hurricanes are going to form, especially well out in advance of the main part of hurricane season. But there's some clues that we can look at for the upcoming season to at least give us some idea. So we can certainly make a forecast of the ranges. For example, will it be sort of a normal hurricane season or less active than normal or more active than normal? And there's some factors that we've seen for this season that seem to indicate it'll be a more active than normal. So you see the forecast here. So normally about 6 or 7 hurricanes. Forecast says more like 6 to 10. So on the more active side, named storms, usually 12 or 13. Forecast for 13 to 19. Then the so-called major hurricanes, category 3 or above, the hurricanes that really can cause lots of damage and devastation if they make a landfall, or even just pass close by to a land mass. Normally 2 or 3 in a year, prediction is 3 to 6. So we're sort of seeing the lower end of the forecast range would be a normal season, the higher end would be a very active season. So hence the takeaway that the best chance is of an active hurricane season. And of course, we're already seeing a quick start to it. Doesn't necessarily mean it's going to be active, but that certainly helps us think, well, okay, there might be a lot of action this summer and fall with hurricanes. Why an active season? So a couple more advanced meteorological factors to quickly touch on. For one, as I've said, the biggest key for hurricanes forming is going to be our warm ocean water temperatures. And this map is showing the ocean water temperatures compared to normal, a so-called anomaly, difference from what it should be right now for late May. So the yellow and orange shows where the water is warmer than normal. The blue shows where it's colder than normal. Here's North and South America, so it's focused on the Atlantic Ocean. Notice how the tropical Atlantic Ocean, the areas between 5 and about 20 degrees, 25 degrees, where we have hurricanes most often forming. Notice that it's mainly in the yellow and orange. So most of the tropical Atlantic Ocean is warmer than normal. So that's one big key. If that pattern persists, if we remain with warmer than normal ocean water, that's more potential energy for hurricanes to form and strengthen with. So certainly the warm ocean temperature is one factor that has our attention. The other factor is a phenomenon called El Nino that you may have heard of before. El Nino actually takes place in the Pacific Ocean, but because the Pacific Ocean is so large, this phenomenon taking place there has a sort of domino effect on the weather and climate across the entire world. And El Nino and its counterpart La Nina, which is essentially the opposite conditions, can sometimes form and persist for several months at a time. So El Nino is maybe what you've heard of the most because it's sort of a reversal of the normal conditions that can lead to some extreme impacts. But as it turns out, El Nino is actually detrimental to Atlantic hurricanes forming. So if there's a strong El Nino during a summer and fall, that often means there's fewer Atlantic hurricanes. Conversely, if there's no El Nino, if there's normal or neutral conditions, or there's a La Nina, which is the opposite of El Nino, that helps facilitate more Atlantic hurricanes. And the reason why is because when there's El Nino, there's more of that so-called wind shear, that change in wind speed and direction as you go higher up from the surface up in the air, which weakens hurricanes. So El Nino fosters more of the wind shear. The neutral or La Nina conditions mean less wind shear. And as it turns out, this sort of complicated looking graph essentially says right now, the best chance for the summer here, June, July, August, September, October, these months here, the gray and blue is these are probability graphs. Notice how the gray and blue are the highest. So gray and blue are the neutral La Nina. Red is El Nino. So notice there's a very low chance of El Nino. which is bad for hurricanes in the Atlantic Ocean, and a better chance of La Nina neutral, which is favorable for hurricanes forming. So the big overall factors are warmer ocean waters and generally the lack of El Nino mean there's better potential for more hurricanes. Still, you never know how things are going to play out, but these overarching factors are showing that there could be a more active season than normal, hence the forecast that we're having here and the quick start. So again, quick start to the season, and yesterday we had our first tropical storm landfall. So tropical storm Bertha, sort of in the blink of an eye, it formed, and then it made landfall, and then it weakened. So it formed early yesterday morning, and made landfall around 9:30 yesterday morning, and then it weakened later in the day. But briefly, it hit that Gulf Stream, the warm water off the southeast coast of the U.S., so it strengthened into a tropical storm. It made landfall with winds about 50 miles per hour, and brought some heavy rain and scattered flooding across the Carolinas up into Virginia. Here's the radar and satellite pictures of Bertha making landfall. Notice how it doesn't really look as classically organized as a hurricane. There's no eye. You don't see that real nice circular rotation. So tropical storms are just sort of less organized hurricanes. If it had had some more time over water, it could have strengthened into a hurricane potentially. But basically, it was over Florida as a very weak system, briefly went over the ocean, and then rammed into South Carolina. So it was not enough time for it to strengthen. But still, it did become a tropical storm. And Bertha is actually having an indirect impact on our weather today. As you can sort of picture, it sort of went straight into South Carolina and moved north over the Appalachians. And because of that broad circulation around the hurricane, that counterclockwise circulation, since Long Island is on the eastern or right side of the tropical cyclone, that means our wind is coming from the south. And a south wind is often to transport into Long Island during the warm season, warmer and moist air from the Gulf Stream and the southeast US, Caribbean Sea. So Bertha, even though its rains have moved well west of us into western Pennsylvania and the Great Lakes, we're actually seeing the larger scale flow around Bertha bringing in that warm, muggy air. So that's why it's feeling so muggy out across Long Island today. It is an indirect impact from Bertha, which is now weakening as it's moved through the United States. All right, so let's look a bit more at the history of some hurricanes that hit Long Island. And if you've been around Long Island for a while, or New York City, or New England, you might even recall some of the storms on the list. As a starter, here's a map of the hurricanes that have hit the continental United States, the lower 48, from 1950 to 2017. So in the second half of the 1900s and the beginning of the 21st century, the 2000s. So the circles are going to correspond to hurricane strength. So the blue, black, and red are the major hurricanes, category 3 or above. And you'll note a so-called magnitude frequency relationship. Most of the hurricanes hitting are in the lower categories, and only a few are in the black and the red there, the category 4 and 5, the ones that bring catastrophic damage. But the ones that do make landfall at that level are, of course, devastating. The really famous hurricanes you hear about. For example, Hurricane Andrew in Florida in 1992, Hurricane Michael actually hit in 2018, so a year after this map was made. The Panhandle of Florida is a category 5. And Camille in 1969 in Mississippi is a category 5. So very few 4s and 5s have made landfall. But even weaker hurricanes can still have significant impacts. You'll note from the Outer Banks, North Carolina, down around to Texas and the Gulf Coast, you see just about everywhere has gotten a hurricane at some point, which shows, since these are the tropics, really the subtropics, hurricanes form in the tropics and often come in to hit these areas. Hurricanes often move east to west across the North Atlantic Ocean, and unfortunately, the United States sticks out. So hurricanes often run into the US. You'll notice not many hurricane landfalls in the mid-Atlantic, but then notice Long Island and New England, there's a secondary maxima in hurricane landfalls. And that's our geography at play. One, the Gulf Stream, helping to keep hurricanes alive, but two, notice how Long Island and New England stick out to the ocean. So unfortunately, since we stick out, hurricanes often turn to the north at our latitude, but as they're moving north, they sometimes plow into Long Island, or at least give it a quick side swipe on its journey north and northeast. So you'll see there's a handful of hurricanes that have hit New England and Long Island just during the 68-year period. Zooming in on Long Island specifically, here's most of the storms that have made landfall since 1851. So about 8 or so hurricanes have directly hit Long Island. You'll note Sandy, for example, hit New Jersey, so it's not on here, but we still got impacts from it. But in terms of hurricanes directly hitting Long Island and bringing those hurricane force winds, there's been about 8 in this 170-year period or so. So as you can imagine, this means, once every 20 years or so, on average, we expect to see a hurricane directly hitting Long Island. Though, of course, that can vary. Sometimes you might have a few hurricanes over a short amount of period. Sometimes you might go a long time without getting hurricanes. Since hurricanes are relatively rare and hurricanes directly hitting Long Island has been more infrequent, there's just some sort of randomness in this. Obviously, there's more hurricanes forming in a year or a decade, there's a better chance one could hit Long Island. But some years there may not be many hurricanes, but it just so happens one of them hits Long Island. There's just lots of sort of random dynamics, just the random nature of the Earth's weather system can play a role here. So anyways, here's the tracks of the hurricanes that have hit Long Island. Notice how generally they're moving to the north and east, and typically they're going to be hitting Suffolk County, the eastern part of Long Island, though a few have made landfall in Nassau and New York City. So here's some historical Long Island hurricanes. They sort of teach us, well, what's the worst it could be for Long Island? And the worst case scenario should be in the back of everyone's mind. Even if it's not very likely in a given year, history tells us it could happen because it's happened before, and there's no reason why it can't happen again. So one of the early famous recorded historical Long Island hurricanes was the 1821 Norfolk and Long Island hurricane. So first it struck Norfolk, Virginia, then it came up and struck Long Island. It was very similar to Sandy, it seems, except it hit more directly on Long Island. So imagine Sandy like surge plus winds over 100 miles per hour. Sandy was bad enough with winds much weaker than that for the most part. So now add the winds and you have a really devastating hurricane that washed away whole small towns around Long Island. Fortunately, it's over 100 years before a direct impact from another hurricane. You had the 1934 hurricane next, which made landfall on Long Island, and that led to drownings and wind damage and flooding. And then after that, you had the very famous storm, the 1938 Long Island Express hurricane. So in the so-called recorded history, since about 1850, when we have pretty good records on hurricanes, this is the strongest hurricane to hit Long Island. And there's some debate, but it's really probably the only Category 3 hurricane to directly hit Long Island. Hurricane that was still a Category 3. It hit Suffolk County. It made landfall in about central Suffolk County. So around the track of the hurricane, essentially the east of it, was where the strongest winds were, and where we had that onshore flow for the surge. So basically, the east end of Long Island is absolutely devastated by this storm. It had 120-mile-per-hour winds at landfall. It devastated those parts of Suffolk County, got the strongest winds. The strongest direct wind gust measured was 109 miles per hour on Fisher's Island, just off the north shore of Long Island near New England. If there were weather stations, we probably would have gotten stronger wind speeds. There just weren't that many back then. It was about an 8-foot storm surge, so a little bit less than Sandy, but still very significant enough to create lots of flooding. About 60 people died just on Long Island, hundreds overall from the storm. And here's just an example of a town in Suffolk County that was totally run over by the hurricane. And now here's the remainder of the list and some other storms that I know there's been some questions about. So then we have the 1944 Great Atlantic Hurricane. It impacted lots of land masses, and its last place to hit was Long Island. It hit Southampton, so the east end of Long Island is Category 2. Fortunately, only the eastern tip of Long Island got impacted significantly, but New England got devastating impacts, the eastern portions of New England. Then some of the ones that might be more familiar for some people, Hurricane Carol in '54, a borderline Category 3 landfall on the east end. It actually was so bad, this was a major hurricane, most likely, that the eastern part of Long Island was totally cut off from the mainland because the Montauk Highway, the only highway back then going all the way out east, was totally washed out in parts of Suffolk. Then Hurricane Donna brushed eastern Long Island as a Category 3 hurricane in 1960, strong winds and surge. And finally, Hurricane Belle in 1976 made landfall around Jones Beach, so a Nassau County landfall. That was a minimal hurricane. Maybe it was not even a hurricane when it finally hit. Might have only been a tropical storm. It really was expected to be devastating, but fortunately, it did weaken. There was still lots of damage, but not as bad as expected because it did weaken a lot. And then finally, Hurricane Gloria is actually the most recent hurricane to directly hit Long Island. That was 1985. Debatable, it might have been a Category 3, probably a Category 2 at landfall. Islip Airport, probably the most reliable weather station in Suffolk County, got 85-mile-per-hour winds. So wind damage, some surge, hundreds of thousands of people lost power. So Gloria is actually the most recent hurricane that directly hit Long Island. Even though we got extreme impacts from Sandy, it did not directly hit us. It made landfall in Cape May, New Jersey. So really, we're still at a drought here of 35 years since Gloria in 1985, which means really we're overdue. Looking at this list, there's often not that big a gap between hurricane landfall. So certainly it could happen any given year. Our next direct hurricane landfall on Long Island, it's been since Gloria. And really, Sandy and Irene were the first storms since Gloria to really have significant impacts on Long Island at all, despite not making landfall as hurricanes. All right, so wrapping up here, we'll just talk a bit about hurricane warning communication, and then we'll take any additional questions. So hopefully this info shown has sort of conveyed to you that hurricanes are uncommon in Long Island. They can happen. They can strike in any given year. And you shouldn't have any preconceived notions. For example, just because we haven't had a direct hurricane impact since Gloria doesn't mean it can't happen this year. And this is an important lesson with Sandy and Irene. It seemed like, oh, maybe hurricanes aren't hitting Long Island anymore, because when Irene impacted Long Island as a tropical storm in 2011, it had been 26 years since Gloria, and there really hadn't been much impact from tropical systems since then. But it could still happen, and Irene showed that. Yet Irene wasn't as bad as feared because it did weaken and did not take that ideal track that Sandy did. So I know in 2012, the next year, a lot of people thought, oh, Irene wasn't that bad, Sandy won't be either. And don't need to tell you what happened to Sandy. So each storm, each season is its own unique beast. So you need to judge each individual storm on its own merits, on its own forecast, and not be biased based on past history, or we've had a lot of storms, so we're not going to get another one, or we haven't had one for a while, so we're not going to get another one, or the last storm wasn't so bad, so this one won't be either. Each storm is its own unique animal. And as I mentioned, there's very complex factors that impact the storms and how they influence Long Island. The exact track, the speed, all these sorts of factors are important and unique to each storm. So it's important to judge the info for a particular storm. The past history can guide us on what to expect in a given year, but then when we look at an individual storm, you just want to look at exactly what's happening with that storm and not worry about other ones or what might have happened in the past exactly. Important to note that we can give a sense of a hurricane season being more active or less active, but a hurricane landfall might only have a few days of notice. At best, maybe 7-8 days of notice. Sandy, for example, about a week before we started saying, this might be a very sticky situation. And unfortunately, it did come to fruition. So the point is, and especially now with everything going on in the world, you really want to make a plan far in advance. So now is the time, before hurricane season really gets going, to have a plan, to have some basic supplies. Again, hopefully you won't need to use them in any given year. It's a low odds that we'll get a direct impact from Hurricane Long Island, but the odds are not zero. There's always a chance. And even if it's not an active season, you still need to monitor things, because all it takes, of course, is one storm. It might only be a couple hurricanes in a year, but one of them could be the one that hits Long Island head on. So obviously, an active year like this one, you should pay really close attention, because there's a better chance. But even a non-active year, or a year that starts off slow, that hurricane that does form could be the one that hits. So you want to make a plan well in advance and have some basic supplies. Obviously, that varies a lot for everyone given the individual circumstances. But I'm sure this pandemic has shown everyone that it's best to be planned in advance for what could possibly happen. Otherwise, there's a run on certain items and it's harder to get things done. So it's better to have things done in advance. And again, some basic things are making sure you know what sort of flooding zone you're in. And then they evacuate based on what sort of flooding zone you're in. So the closer to the coast, the more low-lying area you're in, the worse the flooding can often be. So you want to understand if you're in a flooding zone, what type of flooding zone you're in. That sort of data is available from FEMA and the National Weather Service. And then make a plan based on where you are, your family circumstances, and always think, well, all across Long Island, there could be, say, a week or two of power outages if a hurricane hits. Think back to Sandy. And again, Sandy wasn't even a worst-case wind scenario. A lot of Long Island get winds of over 100 miles per hour with a fast-moving hurricane. Problem is, if a hurricane moves more slowly, there can be more surge and flooding, but it weakens, which is good, so less wind. If a hurricane moves very fast, like that 38 Long Island Express, it doesn't have time to really weaken over the cooler waters near Long Island. So that can allow the hurricane to maintain its strength longer. And that's how Long Island can get 100-mile-per-hour winds from hurricanes. And that's when there can be long-term power outages and issues. So you want to have that worst case scenario in the back of your mind, even though it's unlikely in one given year, it could happen. And as we've learned, it's better to be over-prepared than under-prepared, if at all possible. And our research at Hofstra University deals with how can we improve our communication of weather warnings, specifically hurricanes. And one thing we've been doing is capitalizing on novel forms of technology, specifically immersive technology such as virtual reality, VR, and we create simulations of hurricanes and other storms and put them online and bring them to outreach events and schools and civic organizations. Obviously not right now, but in the past we've done this a lot. As you can imagine, this is a great way to show what a hurricane looks like. Instead of just being in a lecture, you can actually put on a virtual reality headset and see and hear in surround sound in 360-degree video what a hurricane looks like, what it's like to be flooded by storm surge and have strong winds buffeting your home and blowing out windows. And it's especially popular with younger children in elementary school and middle school and high school because it's interactive and sort of cool. So our research deals with how can we improve this sort of novel communication to better help people understand hurricanes. Hurricanes can bring great risk. It's important to prepare in advance. And in addition to lectures and brochures and documents, how can we really get people's attention? And we found that virtual reality and other new technology is a great way to enhance these more traditional forms of communication. So that's all for the content of the lecture today. If you have any questions, here's my Twitter and my contact info. And one last thing to note, I'm the incoming director of our Sustainability Studies graduate program at Hofstra University. We have an MA in Sustainability Studies. It takes about a year and a half or so to complete. You can take classes full-time or part-time. And we study many different issues surrounding Long Island and its natural environment, including things like hurricanes and climate change, along with other ways to try to improve our future and make it more sustainable. So many topics like renewable energy and land use and development and pollution and all sorts of topics like that. So feel free to reach out if you're interested in that program or in anything that we do at Hofstra University, or if you'd like to learn more about hurricanes or have a group that you'd like to have this type of lecture done for. So again, thank you for your time and attention for joining today. And I'll get to some of the questions that have been asked, so feel free to type in questions to chat, and I'll try to get to them. So a few questions coming in. First, how much attention should we pay to hurricane categories since they're based on wind speed? Only on wind speed, but there's other factors of hurricanes. So that's a great question. So that's certainly an important issue. Those categories, and I'll go back to that slide here, are only based on wind speed. So specifically, it's called the Saffir-Simpson Hurricane Wind Scale. So yeah, sort of when you're thinking about a hurricane and looking at the info about it, yeah, the first thing to do is just look at the category. That's the first estimate of its strength and everything. But yes, you also want to look at the surge and the rain and everything like that. So that's when you have to go and look at the advisories being issued by the National Hurricane Center from the U.S. government. And also often your local broadcast meteorologists or meteorologists who are trusted, they follow on social media, will tell you about things like what's the forecast for the storm surge and the rain and the flooding. So you want to really look at all the aspects of the hurricane. So you want to look at the wind, which the category tells you about, but also the water. So forecast for flooding and surge. So yes, very important to look just beyond the categories of hurricane. Are there things that impact how much advance notice people get about hurricanes? So yeah, as I've mentioned, every hurricane a little bit different. There's different conditions that allow them to form and strengthen, and they move with different tracks, and they're in different places, and they have different sizes and speeds and everything. So yes, each hurricane is different. So therefore, some of them are more predictable and some are less predictable. There's always some challenges predicting hurricanes, but some, especially ones that have been moving slowly and have been around for a while, can sometimes be easier to predict. Sort of it's more intuitive to figure out what they're going to do. Sometimes though, especially if the hurricanes are strengthening quickly or are very dynamic and changing a lot, then it can be harder to forecast them. So it's really going to be individual each hurricane, and unfortunately, there's different factors that control the strength of a hurricane versus the track of it. So oftentimes the track part is a little bit easier. We have pretty good luck with forecasting where a hurricane will go. With 3 to 5 days of notice, we're usually pretty good. Sometimes even a week of notice if it's really predictable. But the intensity, the strength of a hurricane is more challenging. So it still can often be very difficult to say how will a hurricane strengthen or weaken. Hurricanes are so unique and they take so many intricate factors that it's just hard to extrapolate out how those factors play out, over several days. So track pretty good, intensity definitely still some challenges. And again, each storm though is going to vary in terms of being more or less predictable. So yeah, if a hurricane sometimes, the weather pattern, the bigger scale weather pattern is pretty predictable, so you can give more advance notice for a hurricane. Sometimes it's just less predictable, or a hurricane strengthens a lot more than expected, or weakens a lot more than expected. So it really does vary by storm. They're all can be a bit different. But usually, again, we find that 3 to 5 days out now, our track focus is pretty good. In terms of how strong it's going to be, that still is often a bit more uncertain. Our instances in which, what's the difference between a hurricane and typhoon? So yes, these are just, let me go back to that map here. Same storm, as it turns out. Just different regional names. So hurricane and typhoon and the cyclone are all the same. They're all tropical systems. Typhoons are often a bit stronger because the Western Pacific Ocean off Japan is the warmest ocean water in the world. So typhoons have a bit higher potential to get stronger, but it's the same storm. Forms the same way, weakens the same way, same characteristics. So hurricanes and typhoons, same exact thing, just different regional names for the same storm. If I lived through a powerful hurricane, I was actually not on Long Island for Sandy and Irene. I was in graduate school at the time in Pennsylvania, so I've not directly lived through a strong hurricane, but being in the inland area, I've still gotten extreme flooding and damage from hurricanes, just not the wind aspect as much. But I've read many books and talked to a lot of people who lived through hurricanes directly, which has informed, for example, the hurricane simulations that I create. It's from eyewitness accounts and looking at raw videos of hurricanes. But being a resident of Long Island now, of course, certainly expecting that I'll live through one at some point. As I've said, Long Island usually does get a hurricane at least every few decades, so we probably will have one again. Well, we will have one again at some point. Obviously, don't know exactly when. Is there an impact between air pollution and severity of hurricanes? Not too much. What's actually interesting is one thing that can impact hurricane formation is large amounts of dust that can get into the air, specifically from the Sahara Desert in Africa. So there's lots of sand and dust from the Saharan Desert. Sometimes it blows from east to west from Africa into the Atlantic Ocean. That can sometimes disrupt hurricanes a bit. But the pollution, we cause at more localized levels is just not nearly as much as some of those natural sources. So in terms of hurricanes being impacted by human pollution, not really. I'm going to see much of a connection. So certainly, the quarantining and limited economic activity has certainly had impacts on air quality and pollution, but there's not really a connection there between that and hurricanes specifically. So that's, especially as hurricanes are forming over the ocean, then obviously there's not pollution really over the oceans because our sources of pollution are land-based traffic and large plants and things like that. So yeah, hurricanes not seeing much of an impact from the pollution specifically. That's not to say there might not be some other impacts from the lack of pollution, but again, not really with hurricanes. How did I start studying weather in particular? You'll often get the same answer from most meteorologists, no matter if they're on TV or if they're teaching it or working in industry, forecasting it. A lot of people really into weather, for whatever reason, just clicked at an early age. So like at age 5 or 6, in my case and many other meteorologists' cases, for whatever reason, we're just drawn to go outside and look at thunderstorms, whatever exciting weather we got in your area, heavy rain, strong winds, big winter storms. So yeah, I just started liking it as a kid and then started reading more about it. and watching the Weather Channel. And yeah, that's how I started learning more about it and getting interested in it. So yeah, again, you'll get the same story from a lot of meteorologists. It just for whatever reason it clicked. Early on, and we just wanted to keep studying it. So it looks like that's about it for the questions. So thanks again for your time and your attention, and for all the interesting questions. Feel free to reach out if you want to ask anything more about hurricanes. I'll just flip back to my contact info here. So once again, I hope you enjoyed this talk and learned something from it. And if there's any questions, feel free to reach out. And the biggest takeaway, of course, is we do have the hurricane season coming up. So just pay careful attention. And if there is going to be impacts from the hurricane locally, make sure to go to trusted sources for your forecasts, and make sure to be ready to take action as needed. So again, thank you for joining today, and take care.